Who can tell me what is the story with similar triangles?
Angle of the triangle.
All the angles of the triangle are the same, okay, in the two different triangles. So they're similar as long as the angles are the same, and they're similar as long as they're...
And all angles are based on 90 degrees. Right.
Okay, that's only for trigonometry, all right, when we're dealing with right angle triangles. But yes, then specific right angle triangles are also similar.
All come down to 180 degrees.
Good, triangles do.
That is what I was going to say.
Okay.
Corresponding angles are equal in ratio.
Okay, the corresponding angles are equal, but the corresponding sides are in proportion. Exactly. So you can take the one triangle, you can blow up all the different lengths, and you can make it all the different lengths twice as big, 3 times as big, square root 3 times as big, to get the new triangle. All right.
Well, they're obviously equal in shape, similar triangles.
Sorry?
Well, they're obviously equal in
Exactly.
shape.
Exactly. So they're similar, the shapes look the same. And that's because the angles are all the same and the sides are all in proportion with each other. Great. So then what's the specific story about right angle triangles?
They consist of a right angle.
Okay, they consist of a right angle, good. And then what does that allow us? Okay, so not only can we take similar triangles now, make them bigger and bigger and play with the different sides of these right angle triangles, we've also learned now that the different sides of the right angle triangle, so your hypotenuse, your opposite side of the angle we're talking about, and the adjacent side of the angle we're talking about, are all in relation to each other. Okay, we're going to use that fact a lot today. Sine, cos, and tan. What is sine? The ratios of, let's draw your triangle so you can get a little bit of help here. There's your 90 degree. Here's, let's just call this A, B, C. And that there is theta. Okay, so sine of theta. Who can tell me what it is in the ratio there? Yeah.
Rephrase
The question, all right. So what is sine of theta with regards to that triangle?
Isn't it,
Yeah?
okay, isn't it A over B?
Okay.
Divided by C.
Can you tell me what was the acronym you used for sine, cos, and tan?
Pi.
Good. Okay, we got SOHCAHTOA here. All right. Nice way to remember it. What does that actually mean? Sine is equal to hypotenuse over. Sorry, not hypotenuse. There we go. Guys, it's late. What can I say? Opposite over hypotenuse. All right. Cos is equal to? Good. And tan is equal to? Exactly right. Okay, so let's have a look here with regards to this triangle. If we're looking from the angle of this, from the perspective of this angle here, what is sine? Ashley? B over A. Awesome. What is cos? Someone else. Shanli.
I think it's B over C or C
All right.
over I.
Let's have a look. Okay, cos is the adjacent side. Which is the adjacent side? Which adjacent means? Okay, right next door to. Adjacent just means that you're sitting, I don't know, you more Afrikaans or English?
Yeah, Afrikaans.
What is the word for adjacent in Afrikaans? Like right next door.
Reg langs aan die een met 'n
Yeah, that.
Teenoorstaande.
Tegenverstaande. There we go. Okay, so adjacent means literally right next door. So that's
C over C.
C over hypotenuse. C over A. Brilliant, Victor. Tan is?
C over C.
Opposite side, B divided by C. Fantastic. Okay, so we got the basic trig stuff down. So now we touched on this yesterday. It was a bit of a rush. I just want to recap the ideas so we can just make sure that you guys are solid there, and then we're going to move on to the pretty interesting stuff for today. Yes?
I'm sorry, but how is that right next to each other?
Oh, okay.
Because
Theta. All right. Which two sides are next door to theta?
I am
A and C. All right. But what is A's name? Okay. The thing with right angle triangles, and somebody came along one day and said, well, actually probably Mr. Pythagoras himself, but I'm not actually sure, so I'd have to check that up before I say it on TV. But the thing with right angle triangles is the side that's opposite to the right angle. Okay, so always the longest side of this triangle, but the side opposite to the right angle is always, always called the hypotenuse of that triangle. Okay, so he always has a name. You never have to worry about A. A is the easy one to get. All right, it's C that can change sometimes, because if I'm this angle here, which one is now next door to me? It's C. Okay, so H is also next door to me. But, sorry, A is also next door to me, but he's the hypotenuse. So I've given him a name already. So I need a name for this one. So I have to now come up with a new name that's going to talk to C. Okay? All right, let's have a look at it this way. You've got an angle. Picture yourself sitting in a big triangular room. Okay? There's a triangle between you, me, and Lorato. Okay? Are you the 90 degree? Can you see the triangle? Draw the triangle. Lorato to you, to me, and back again. Okay, so you the 90 degree. So where's the hypotenuse sitting? It's sitting over here, exactly. Brilliant, okay? So now from my perspective, which two sides are right next door to me? This one here and this one here, okay? But this one here already has a name. Okay, we've called this one the hypotenuse. So which one's this one? Okay, no, but it's right next door. So what is right next door? The same word. Adjacent. Adjacent, okay. So you just got to try and remember that word adjacent, because it's a bit tricky, okay? Opposite now, what's that side sitting there? You guys are all on that side. Okay, you're opposite me. You're on the other side of the triangle to me. But now from Lorato's perspective, okay? From Lorato, who's adjacent to her? Give it a go, give it a bash.
Us.
Okay, what does adjacent mean again?
Just right next door.
Next door. So who's sitting next door to Lorato?
Hunter.
Hunter is. Okay, exactly. So which side now forms the adjacent side?
My side.
Your side. So you have now become the adjacent side, all right? And this side has become the opposite side. So it's the same thing for the triangle. Theta sits here. Which is the hypotenuse? Okay, why do you say
Because I also
A? No, it's not a good enough reason for me.
I don't know.
Okay.
I really don't understand this.
All right.
I actually don't.
Let's go back to the rule, okay? The rule said opposite the 90 degree sits what? Hypotenuse. It's 3 words. Okay, let's go. Hypotenuse, opposite, and adjacent. All right. Opposite the 90 degrees always sits the hypotenuse. Always, always, always. Okay, so we can write big H for hypotenuse. That's never, ever going to change. Whether I turn the triangle upside down, flip it inside out, change the theta to an alpha there, or whatever the case is, the hypotenuse is always the side, I'll be with you now, Liesl, is always the side opposite the 90 degree angle. Okay, now from the theta's perspective, which two sides sit right next door to theta?
C and A.
C and A, brilliant. Okay, there you go, so now you thought of it. So which sides sit adjacent to theta? Yeah. C and A. Okay, no, both, C and A. They're both adjacent, okay? Because remember, adjacent means next door to.
But you just said A is...
Exactly, okay? So because both of them are right next door to theta, this one already has a name. So which is the only one left?
C.
It's C. There you go, okay? Which one is the opposite side?
B.
B, that one's easy, okay? But now if I got alpha there, okay? We're looking now from this perspective. Which two sides are adjacent to alpha?
B and A.
B and A. But what is A? Hypotenuse. Okay, remember A doesn't ever change. It's the hypotenuse.
Okay.
That one's easy, okay? But which one's adjacent to its B? Okay, so B is the adjacent side, C is the opposite side, and A is always the hypotenuse.
So A, okay, you said A is always whatever that word is.
Hypotenuse. Call it the hippopotamus if you want to. I'm okay with that too.
Hypotenuse or whatever. So, and then if I watch from this, then B always is that, yeah, or C is that, whatever.
Yes, okay, just try and remember those two words. The opposite, opposite's easy. Adjacent, is, I can understand, it's quite tricky.
Jason.
Adjacent, there you go. So if you're sitting adjacent, you're sitting next door to.
Okay.
All right, Lisa, we had a question.
I was going to say she can just say, in order to determine the hypotenuse, she must just look for the longer side.
Brilliant.
Because in a right angle triangle, it's always the longer
Fantastic. Couldn't have said it better. All right, so hypotenuse is always the longest side. Always a side opposite the 90-degree triangle.
Like always
90.
like so.
Exactly, you got it. Cool. So we just want to run through and now figure out sine, cos, and tan for each of these angles because they are angles that pop up quite often because in maths they come out to be nice numbers, okay, as we found. And square root of 3 is a nice number. Okay, by the way, as we had a big discussion yesterday, it's a good number, right? And so we're going to run through and just quickly find out exactly what sine, cos, and tan equal for each of these angles, picturing the triangle that they form. Because remember, trigonometry always has to do with triangles. As soon as you don't picture the triangle in your mind, then you're going to struggle with trigonometry. So the very first thing, even if you're stuck, draw the triangle and write hypotenuse, write adjacent side, write opposite side. I'm completely okay with that. That means that you're just breaking the problem down in your mind. All right. So let's have a look. For the first one, actually, let's do it this way. We're trying to figure out sine of 0. Okay. What is this angle here? It's going to theta, but now we want to put theta and make theta a specific example. So instead of theta can just be any angle, we're making theta equal to 0. Great. What does an angle of 0 do? It squishes. So it takes this side and it squishes it all the way down.
So it's basically a line.
Okay, so do we have a triangle?
No.
Whew, that's a problem. Okay, so do we?
Yeah,
Okay. Can you explain?
because just to be honest, okay, because your reaction told me yes, it does.
Okay. The problem is it doesn't.
Good explanation.
That's not a good explanation. Can you do better?
No.
Okay.
He questioned your reaction, so you must have a better explanation.
No, it's okay. We're going to run through the explanation now. All right. So we're taking this side here and we're squashing it down, making this angle 0. Okay, but now we've lost the triangle.
It's not a triangle because then it's a line.
It's a line. It's not a triangle. So we've broken the rules. Okay, so we have broken the rules. That is the problem. So what we're going to do is instead of now trying to picture this line, we're going to try and figure out what happens when we squish this thing really close to 0 without actually getting to 0. Okay, in maths, you might have heard of something called a limit. Okay, that's pretty much what a limit does. It takes something and it has a look. It's like having a microscope and looking in much deeper and much closer to the problem. But now you're just going to think about it a little bit, okay? So we're going to now take this line and draw the triangle much closer. Okay, so not quite, but just not quite 0. It's not quite 0, but it's much closer.
Okay, so I'm just saying, so the 0 degrees only starts there at that specific point because it goes up like this. So does that basically mean the 0 degrees is only for
Remember, we're measuring 0 between this line there and that line. So we're measuring the angle between the bottom line and the hypotenuse, okay? So we're now trying to figure out what happens as that angle goes to 0. But let's have a look. Let's start with sine. Just bear with me for a bit. This is a triangle. Do you agree, the green one? The green one's a triangle. Let's just for a second in our mind picture the fact that that angle is 0, but it's just a little bit bigger than 0. So we just still have this triangle just existing. What is this side?
90
That is
degrees.
the
Okay? No, okay, this there is the 90-degree angle. I'm asking, what is this side there? Opposite side. Brilliant. Okay, that's the opposite side to the angle there. Great. As I squish this line, the green line, closer and closer and closer and closer to the blue line, what does that side become?
It won't be adjacent to one.
No, it'll still be the opposite. Okay, but I'm asking how big will it be? How long? How much of that will you be able to see? Become shorter and become shorter and become shorter until what?
Until it's just a line.
Until it's just, okay, but what is this one? What is the length of this line become?
Nothing.
Brilliant.